you need some help with solving equations, you've come to the right place, because we are going to solve some equations. So let's take a look at the ones we've got. When solving equations, you can have some pretty simple ones, but remember there's a few ideas, a few steps that we're thinking about. So whenever we're solving an equation, we're trying to get the variable by itself alone. They often call this isolate the variable. That's the way we're going to do it. And then to do that, we're going to use those properties. So addition, subtraction, properties of equality, multiplication, division, distribution, substitution. We're going to use all of those properties to be able to create equivalent equations which will then finally lead us to the point where we get that variable all by itself. And to create those equivalent equations, we're thinking inverses. To get the variable by itself, we're going to have to undo what's been done to it. So we think about inverses. And the main inverses we think about, plus and minus. They're inverses. They undo each other. And multiply and divide. They're inverses. They undo each other as well. So if we take a look at that first problem, I've got n minus 11 equals 9. So what that is telling me is if we take our variable, subtract 11 from it, it's going to equal 9. So then I think, well, what's the inverse of subtracting 11? Because I want to do the opposite. Well, the inverse is adding 11. Make that plus sign a little better. So we're adding 11. Then we have to use the properties, because I can't just add 11 to one side, so I have to add 11 to the other side. So then negative 11 plus 11, those cancel out, leaving me with 0, which we know from our properties that adding 0 does nothing, so we just get rid of it. And then 9 plus 11 gives us 20. Now we've got an equivalent equation, n equals 20. But this equivalent equation, the variable is by itself, so that's what we're trying to get to. Now we don't usually think about all these steps here when we're doing this. So it's alright if you're not really thinking about that, but that's the essential piece of what's going on here. So if we look at number 3, negative 2 equals a plus 13. So if I add 13 to a, I'm going to get negative 2. But I want to know what a is. So I do the inverse to a. I subtract 13. Because I have to use my properties, I did it to one side, I have to do it to the other side. I have to subtract 13. So 13 minus 13 would give me 0, but we know that adding 0 doesn't do anything, so I'm left with a equals negative 2 minus 13 is a negative 15. Now let's take a look at number 5. This time I've got x divided by 6 equals negative 3. So if I divide x by 6, I'm getting negative 3, but I want to figure out what is x. So I do the opposite. I multiply both sides by 6. Doing that inverse. Dividing by 6 and timesing by 6 cancels out and leaves me with 1. But I know that 1x is the same as just x because of that additive property of 1. Then 6 times negative 3 gives me negative 18. I've got my equivalent equation that provides for me the answer of this other equation. Okay, last one on this page, number 7. Negative 3 times k equals negative 54. So here we're timesing k by negative 3, so I've got to do the opposite. I've got to divide by a negative 3. Because of my properties, I've got to do the opposite. So, I've got to do the same thing to both sides. So negative 3 over negative 3 gives me 1. I know that 1k is the same as k. Then negative 54 divided by negative 3 will give me a positive 18. Because a negative divided by a negative gives me a positive. So once again, k equals 18 is an equivalent equation to negative 3k equals negative 54. Okay, they just look a little different, but I can get to one from the other. Okay, those are the easy ones. Let's take a look at some harder ones. So this time in 11 we've got 32 equals negative 4 minus 3x. So that x is first being multiplied by 3, then we're subtracting it from negative 4. So I'm thinking I've got to work backwards from this. That's what I'm thinking. So I'm going to have to first get rid. Sorry, somebody came into my room and now I forgot where I was at. Anyway, we've got negative 4 minus 3x. So that x, we're multiplying it by 3, then we're subtracting it from negative 4. So we've got to do the opposite. First we're going to deal with this negative 4, then we'll deal with the 3. We're thinking in opposite ways when we're solving. It's a negative 4, so I've got to do the inverse. I've got to add 4 to both sides. The properties tell me I have to add 4 to both sides. Negative 4 plus 4, that's going to eliminate it and be 0. But we know that's not going to change anything, so we just put negative 3x. Then 32 plus 4 gives me 36. Now we can get rid of that negative 3. It's multiplying, so I think inverse, I think divide. So I'm going to divide by negative 3. Negative 3 over negative 3 gives me 1. I know that 1x just ends up being x. 36 divided by negative 3 is going to give me a negative 12. And now I've made an equivalent equation, another equivalent equation. I've made 3 equivalent equations here. And they've helped me step by step get down to where I've got x by itself. Let's take a look at number 12 now. So number 12, we're going 3 times x plus 9. So I take 3, I multiply it by my variable, then we add 9 to it, and that's going to get us 36. So I need to think about this backwards. Instead of multiplying first, I'm going to get rid of that 9 first. So we do the inverse, we subtract 9 from both sides. 9 minus 9 gives me that 0. And as I've been mentioning, but I just thought I'd show it this time, so that we can double check to make sure we know what's going on. Then 37 minus 9 would give us 27. Because we did it to one side, we have to do it to the others. I know because of my property, the additive property of 0 tells me that's going to get eliminated. So I'm left with 3x equals 27. Now we can divide the 3 because we were multiplying it by our x, so we do the opposite. Gives me 1x equals 27 divided by 3 gives me 9. I know I can get rid of that 1 because of the multiplicative inverse, or multiplicative property of 1. And we're left with 9 equals x. So when we're solving equations, we're simply thinking, I've got to do the opposite of what's been done. That's what we are thinking when we're dealing with this stuff. Should we take a look at another? Alright, so this time we've got to deal with the distribution. So here I'm thinking, I've got my variable r. I would multiply it by 3, subtract that from 7, times it by negative 3, and that would give me negative 93. So we've got to deal with it the same way. Now there's 2 ways we could deal with this one. If you're thinking opposite ways, you'd probably want to divide by a negative 3 first. And you could do that. Those would cancel. That'd leave you with 7 minus 3r equals negative 93 divided by 3 is 31. Then we would have to get rid of this 7, thinking opposites. So we do the inverse, subtract 7, gives me negative 3r equals 31 minus 7 would give me 24. Divide by negative 3, and we'd get r equals negative 8. So that's one way we could do that. Okay, the problem is if we look at number 15, if I wanted to do that same thing. Because here, we've got negative 3 times b, we add 1 to it, then we times it by negative 3. On the left side, we've got 37 plus b. Well, if I try to divide by negative 3, I'm going to end up with 37 over negative 3 plus b over negative 3. And that's not quite so easy to deal with. So, it might be best to simplify things before we have to deal with them, because we can do that. We could have done it on number 13 as well. I'll show you actually here. So let's take a look at the other way we could have done 13. We could have said, well, let's simplify this side, because I know because of the distributive property I can multiply negative 3 by 7 and by negative 3r. So then we'd get negative 21 plus 9r equals negative 93. Then we would just simply have to add 21 to both sides, leaving us with 9r equals negative 93 plus 21, When you have a negative and you're adding a smaller number to it, it's kind of like you're subtracting. So that would be 2 and 7. So 72 in the negative, right? So then we divide by a 9, and we end up with r equals negative 8, because that's a negative 72, looked like my equal sign. So same thing. Might be easier, might be harder. Number 15, it makes it a lot easier. Because as we multiply, we get a positive 9b minus a 3. That would equal a 37 plus b equals 9b minus 3. Then normally we would add 3 to both sides. So I'd end up with 40 plus b equals 9b. But now I've got to get this other b out of here. So I do the inverse, I subtract b. Now when we don't have a number with our variable, we can put a 1 there. So 9 minus 1b would give us 8b, which equals 40. Divide by 8 for our last step, and we get 5 equals b. So 15, a lot easier to do it this way, simplifying first. 13, you could have chosen either way. So 2 more problems. Now we've got even more steps we have to do, but we just keep doing it piece by piece. We still follow the same process, and we do it just piece by piece. So first thing I want to do is probably simplify these parentheses. 6 times v would give me 6v, plus 6 times 6 would give me 36. Then negative 3 times v would give me a negative 3v, and negative 3 times 3 would give us a negative 9. All that equals 27. But I'm still thinking opposite, but first I want to simplify things as best I can. 6v and negative 3v we can combine. 6 minus 3 would give us 3v. 36 and negative 9 we can combine. 36 minus 9 gives us plus 27. And that equals 27. Then I subtract 27 from both sides. That leaves me with 3v on the right. 27 minus 27 is 0. You may think that, oh crap, I did something wrong. No, you can have that. Because if we divide by 3, 0 divided by 3 is still 0. And that's our answer. It's the only way to get this to work. Okay, number 19. Same idea. This time we've got quite a few variables here, but we still treat it the same way. First I would multiply here, simplify it as much as I can before I start doing inverses. 2x plus 8 times x is 8x, 8 times negative 8 is negative 64, equals, and I apparently ran out of room. Hold on. Guess I'm going to have to try to write smaller on this one. So we've got 2x plus 8x minus 64 equals 2x plus 4 times 2x is 8x plus 4 times 1 is 4. Now combine all the like terms. 2x plus 8x, 2 plus 8 would give me 10. And we leave the x, minus 64 equals 2x plus 8x would give me 10 again, plus 4. Then we would combine like terms. So we could add 64 and get it to this other side. We'd end up with 68 plus 10x equals 10x. Subtract 10x. 10x minus 10x gives us 0 equals 68. Okay, sometimes we run into this where an equation actually doesn't work out. 0 is not equal to 68, so this is, you would just write there's no solution. You can't solve this one. Doesn't work. Sometimes that happens. Okay, sometimes that happens. Alright, so that's basically it. Hopefully you can get the other ones done and shouldn't have any problems. Now, to continue our story we left off, the black ninja had just disappeared. Let us see what happens. Oh no, he appears above the river. Now over there. What madness is this? Oh no, he's created extras, and they're going to attack the purple ninja. To be continued.